let's jump into the next example. This time we're going to do the same process. So you're going to see it one more time, except for we're going to try to graph it for a solution. So we can see it in a little bit different fashion. So again, f of x is both solved for here. So I'm going to start out by setting them equal to each other. So x squared minus 2x minus 1 equals x plus 3. I'm going to go ahead and move the x and the 3 from the right side to the left side, right? Those turn into 0, and on the right, that's what I want. That means I'm going to solve, so I get x squared minus 3x minus 4. And this one, again, we should check to see if it's factorable, because factoring for me, if it works, is my favorite method. You might want to try the quadratic formula here. That's perfectly fine. Square roots, of course, won't work because we have a linear term, so that's not going to work in there. But you could try the quadratic formula. So a times c is going to be 1 times negative 4 or negative 4 that combine to make negative 3 on the bottom. Is that possible? I believe it is. If I make a negative 4 and a positive 1. So again, if I go ahead and factor this, I'm going to have x minus 4, and I'm going to have x plus 1 equal to 0. So that means that my 2x coordinates are going to be 4 and negative 1. So now that I've got my x coordinates, I need to plug them back into one of the two equations and verify what the y coordinate will be. So in this case, I'm going to go back to the linear one because it's the easier of the two. So let's evaluate it. F of 4 equals 4 plus 3 or 7. So I get the point 4, 7 is a possible solution. Let's evaluate for the other x coordinate then. So f of negative 1 equals negative 1 plus 3, or I get 2. So the other coordinate is going to be negative 1, 2. So there's my two possible solutions. So to graph these then, I'm going to go ahead and graph with my techniques that I learned previously. So the first technique I'm going to do is I'm going to jump on the linear because that's a heck of a lot easier than addressing the quadratic to start. So I remember that the 3 is my y-intercept. I'm going to go there. And I'm going to put a 3 on the y-axis. Perfect. And then I'm also going to remember that 1 over 1 is my slope there because I can't see it, so it's a rise over run, which means that I'm going to be up 1 and over 1 in both directions, or down 1 and left 1 will also be an appropriate way to draw that. So I'm going to have a linear function that looks about like that. So I've got one of the two graphed. Now I'm going to graph my quadratic. So this quadratic here, I know I've got a y-intercept already, so great for me because my y-intercept is my c value. So my y-intercept is 0, negative 1. So let's put that down. 0, negative 1. So there's my y-intercept so far. I probably should find the vertex. So that's what I'm going to go to next. And in finding the vertex, I guess I'm going to find the axis of symmetry as well. So, because remember, the axis of symmetry and the x-coordinate of my vertex is going to come from, right, the h value, which comes from opposite b over 2a. And in this case, my a value, or my b value is negative 2, so negative 2. Don't forget there's two negatives, right? And then I'm going to put that over twice my a value, which is 1. So 2 times 1. So I'm going to get a positive 2 on top and a positive 2 on the bottom. So a value is, or my h value is 1. So far I've got that piece of information. Okay, and I also have my axis of symmetry. So let's put that down on our graph. So my axis of symmetry will be this purple dashed line right here. So now I know where my symmetry is going. I should probably also note right here that my a value is positive, which means that I'm going to be opening upward. Okay, so I know that my vertex is going to go somewhere in that direction so far. So let's go ahead and take our other piece of information here, which is the x-coordinate, and I'm going to evaluate the function for that so I can find out what my, y-coordinate is. So I'm going to find out what this coordinate is by plugging in x value. So let's see what that looks like. I'm going to have f of 1, which is going to be equal to 1 squared minus 2 times 1 minus 1. So what does that calculate to be? We get 1 minus 2 minus 1. It looks like I'm going to have negative 2. So my vertex then is 1, negative 2. So let's place that 1, negative 2. And notice how I drew the quadratic off of the y-intercept there. That was not an appropriate way to do that. Oh, I put my axis of symmetry on 0. That was not my not my point that I wanted to do there. Sorry, I went through the wrong spot. Hopefully you were following along and you're like, wait, Mr. Hallam, wait, that's not right. Yeah, you got me. Well, let's put it down through the vertex because it said x equals 1, not 0, where I graphed it. All right, that makes a little more sense. Now we've got our vertex on our axis of symmetry. They do match. It's exactly like we want. Additionally, I'm going to take that y-intercept again, which is 0, -1, and I'm going to use a free point, right? It's 1 unit away from my axis of symmetry, so I get 1 free point here. Great, I'm not doing too bad here. I can solve to find the x-intercepts if I wanted to, or I can be efficient and just plug in for any additional point. And because the x-intercepts aren't too important to me right now, I'm going to go ahead and pick another point. So let's say -1 or 2, 2 we've already got, right? So 3. So f of -1 might be the way to go, or f of 3. So we'll plug in f of -1. So I'm going to get -1 squared minus -2 times -1 minus 1. So what do we get from that? I get a +1 when that -1 squares. This is going to turn into a +2 minus 1. So that's going to turn into a +2. So I get the point 1, -1, and 2. So let's plot that and see what we get. So -1 and 2. Hey, look at that. It's actually one of our solutions, which coincidentally was going to get me another point as well. So I get 1, 2 away from the axis of symmetry. So I get another free point by going 2 more over. And now I've got enough to graph my parabola. And we've already got one of our solutions right there. So we've completely verified it graphing it there because it is the same point for both functions. And let's see if that other point, if we sketch this well enough, because we've got 5 points, so we should be pretty accurate. Let's see if that other one is close enough for us to say that's good. So we verified the point right here, right? -1, 2. This one checks. That's verified. That is a solution. The other one should be 4 and 7. So let's check. Here's 4 and here's 7. And look, we're pretty close. I think that if we graphed that a little cleaner, it would be exactly on top. That's good enough for me to verify that that's also a solution. So now that we've done that, we've got one more thing we should try here. So let's see another little thing here. I'm going to bring up that we're going to do another one. You're like, oh, I can't handle another one. But something that we could try. Do you remember the discriminant? And you remember what discriminant did? It told us how many solutions there are. Remember, the discriminant's a really quick calculation. B squared minus 4ac. And if we do that quick calculation, it can tell us if it's even worth going through all the work that we've been doing. If there's no solution, then we stop and it's not worth solving. So let's check out if we can try this discriminant. So how do we employ the discriminant on this system to see if there's a solution? Well, we do what we've been doing by setting them equal to 0, right? So this f of x, that value is going to go in there for that f of x at that linear. So I'm going to take x plus 2 equals 2x squared plus 3, right? I'm going to go ahead and subtract it over like I have done. All right, those are going to turn into 0, minus the 2 over here as well. So I've got 0 equals 2x squared. This negative x doesn't have a like term, so it's just going to sneak in there. And I've got 3 and minus 2, which is going to be a +1. Now that I've got it down to a single quadratic, I'm going to pull off the coordinates and check it in the discriminant. So my a value is 2, my b value is -1, and my c value is also 1. So let's check it and see what we get. So I got -1 squared minus 4 times my a value is 2 times my c value is 1. -1 squared is 1, and this is going to be a -4 times 2 times 1, which is -8. We get -7. You know what that means? Negative values means that there's no solutions. So right there, that quick little check by doing the discriminant, especially if you do the quadratic formula, tells us this isn't worth solving because we're going to end up with, let me scroll back up here, this possible solution here. So now that we're all done, let's summarize. What did we do? Algebraically is how we're solving these. We said we got to make sure that they're y-equal. Then we take both of the equations and set them equal to each other, in which case we should come up with either a quadratic function or a linear. We didn't see any linears, but it's possible, right? That's going to solve, that we're going to get down there and we're going to solve them. If it's quadratic, like the ones we did, we're going to factor, square root, or quadratic formula from that. Once we've done that, we're going to go ahead and plug those x coordinates in, because that's what we're getting, to find the whole point, the x coordinate and the y coordinate. right? And then after that, we're going to check those solutions by either plugging them in to find a truth statement, or we're going to graph and visually verify that they're solutions. All right, thanks for watching. We'll see you in class for some examples.